Welcome back to College Algebra. We're in the series on the basics, and today we're talking about division with fractions. We learned last time how to multiply fractions together, and today we're going to learn how to divide fractions. We're going to start today's discussion with a very simple example, a very simple multiplication example, but this example is going to motivate everything that we do for the rest of the day. We're going to start with the example of 3/4 times 4/3. If you look closely, you might already see what the answer is, but let's pretend that we can't just look and see the answer, and let's work through it. And what you'll notice is we get, when you multiply across both the numerator and denominator. So we get 12 on the numerator and 12 on the denominator. 12 divided by 12 is just the same as 1. And so what you see is that when you multiply any fraction by the opposite fraction, the fraction with the same two numbers but in the opposite order, you get the answer 1. And you'd expect this to always happen. We could have also thought of this in terms of cancellation. We've seen that the 3's cancel and the 4's cancel, leaving us just 1 over 1 for our result. This is what we call in mathematics a reciprocal. And so this 4/3 is the reciprocal of 3/4. And reciprocals are really important in the world of fractions. They're what we will later refer to as inverses. They're things that undo an action. And so reciprocals are able to undo a certain type of fraction multiplication by turning them into something similar, something like 1. So we use it. So this is called a reciprocal, and this is actually the key to using fraction multiplication. So let's start with the problem. What if we have 5/2 divided by 3/4? I wrote this as a fraction problem with a big divide bar because I think it might be easier for us to think about it this way. Remember, the bars, the fraction bars, are really just divided by signs. So you could say this is 5 divided by 4 divided by 3 divided by 4. Now when we think about this, you remember when we were simplifying fractions, we're able to multiply and divide both the top and bottom of a fraction and end up with the same answer. So what I'm going to do is I'm going to try to make it where this bottom no longer exists. So my goal is to multiply by something that would make this bottom part no longer part of the problem. And what that is I multiply by is the reciprocal. Notice if I multiply the reciprocal on the bottom, then all of a sudden this bottom part is going to equal just 1 on the bottom. But remember, from simplifying, we don't just multiply on the bottom, we multiply on both the top and the bottom, and it leaves the fraction unchanged. And so if we multiply the top by 4/3 also, then we end up with a new problem, 5/2 times 4/3. And so what's important is to realize that these two problems that we started with, 5/2 divided by 3/4, and this new problem that we've created, by the way, when you divide by 1, it stays the same. This new problem that we've created, 5/2 times 4/3, are actually the same problem. So these are the exact same thing. So to divide by 3/4 is the same as to multiply by 4/3. This is the basic principle that you've probably heard before, and it says to divide fractions we multiply by the reciprocal. But we'll multiply by the reciprocal on the denominator, the reciprocal of the bottom. So when we multiply by that reciprocal, it comes up here and we have a new multiplication problem. This will become important because later on in the semester we'll be trying to divide complicated things with x's and roots and powers in here. But this principle is always going to hold when we're dividing things that are fractions, where it's the same as multiplying by reciprocals. Now let's go ahead and finish this problem off and get our answer. Notice this one is hard to think about. This one's easy to think about because we've already done a lot of things like it. Let's multiply across the top and get 20. Multiply across the bottom and get 6. Let me go ahead and simplify that by dividing both the top and bottom by 2, and then we'll get 10 over 3, which is a pretty reasonable answer. So again, that brings us back to our main principle. To divide fractions, you multiply by the reciprocal. We don't do it because it's magic. We don't do it because the textbook told us to. We do it because the reciprocal is the way that we can take the bottom part of this fraction and turn it into a 1. That's the way we can get this bottom part of the fraction to not be there anymore, to not be a problem anymore. Let's work on another problem. This time I'll write my division using the more traditional division notation. However, I'll say this is traditional in middle school, high school mathematics. Once you move into upper division mathematics, people rarely ever use this division symbol. But we'll do 7/3 divided by 7/15. How do we solve this? Let's go to our principle. We always multiply by the reciprocal. So this problem is solved by taking 7/3 and multiplying 7/3 times 15 over 7. Notice we always take the reciprocal of the right-hand side because the right-hand side was the part that was under the fraction. If you remember the last problem, it was the part under the fraction that we wanted to undo. It was the part under the fraction that we wanted to get rid of. So it's the reciprocal only of the part that's being divided by this right-hand side. Okay, let's go ahead and solve this. Tell you what, to solve this, I'm going to look first and see if there's some simplifying I can do. And the answer is yes. This 7 and this 7 can divide together to give us 1. 15 can be rewritten as 3 times 5. And this 3 can divide together to give us 1. So what does that make our answer? Well, if you look on the top, you see we have just a 5 remaining. What's left on the bottom? Well, the answer is, you might say there's nothing left on the bottom, but I don't think that's appropriate. I think there actually is something left on the bottom. What's left on the bottom is a 1. Because when these things canceled, they didn't disappear. It's not like they canceled and poofed into oblivion or something. This isn't a video game. What happened is they divided by each other. 3 divided by the 3 to make the number 1. 7 divided by the 7 to make the number 1. And we could have written 1 and 1's in the numerator, but notice when you multiply by 1, it has no effect on the problem anymore. So when these things cancel, what they actually do is they're actually turning into 1's instead of remaining the numbers that they are. We get 5 divided by 1, which has a simpler solution of just 5. Okay, well, since we've done so much work on multiplication already, I think you're ready for your practice problems. Try these two problems, pause your device, see if you can be successful in solving them, and then come back here in a few moments and we'll work them together. And we're back. Let's start with this first problem. What am I going to do? I'm going to change this into a multiplication problem by multiplying by the reciprocal of the bottom. So this is what I want the reciprocal of. So I'm going to multiply by 7/6, and I'm also going to multiply the top by 7/6. You notice that makes the bottom equal to 1, and so that means this problem is the same as the problem 2/3 times 7/6. Again, it's not magic, it's just turning the bottom into 1. We turn the bottom into 1, this 6/7 now turns into a multiplication by 7/6. Let's go ahead and multiply this across and see what we get. We get 7 times 2 is 14. 6 times 3 is 6, 12, 18. I'm going to go ahead and simplify. Let's simplify it by dividing both of these by 2. I'll divide by 2 and divide by 2. And then I'll get 14 divided by 2 is 7. 18 divided by 2 is 9. So it looks like 7 divided by 9 is our answer. Okay, let's work on our next problem and see how it goes. Again, this is a division problem. Let's change it to a multiplication problem. 4 divided by 15 times 5 over 8. Let's do this one instead of multiplying and simplifying. Let's go ahead and cancel what we can cancel. I'll notice that 8 is the same as 2 times 4. And so now those 4's cancel each other. What they really do is they really turn into 1's, right? 15 is the same as 3 times 5. These 5's cancel with each other. What that really means is that they're turning into 1's. So I've done my canceling. I've looked at this problem and simplified it. What I have left on the bottom is I have a 3 times 1 times 2 times 1. So I have 6 on the bottom. On the top, it's not nothing. It's tempting to say that the entire top is canceled and there's nothing there. In fact, there is something there. It's the 1s that those turned into. So it's actually 1/6. So our answer is 1/6 because every time we did canceling, those two things just simplified into a multiplication by 1. All right, I hope that this helped, and good luck, and we'll see you next time.